Good morning, everyone. Today, we are so excited to have Dr. Naeimi from Netherlands. He's working in the governmental office in the rail industry of Netherlands. He's talking now. He would talk about application of data science in his field. And let's just, without further ado, let him to get the control of the today meeting. And thank you very much for all the audiences. Dr. Naimi, please start.
Yes, I would start quite shortly, but before that, I want to share my other screen because it was easier. With this screen, you don't have the full presentation.
Okay.
Let me see how to change my share, new share. Oh, this one, yes. I do that one more time, and then I show my presentation here. Try to do it again. All right, can you see this?
Yeah,
In the full demonstration mode, I guess, so?
is a full mode, crystal clear.
Very nice. Let me see here. Okay. Thanks for the introduction. I just want to add to your short introduction that I'm now working more or less in the industry, so I'm less involved with research or the academia. But of course, I have some communications and connections yet with the university people, students, and also with the supervisors who have been involved during my years of PhD at the TU Delft. All right, let's start with this presentation. The title says Data Science in Railways, Research and Practice. As you can imagine, the data science is used almost everywhere in every discipline of research or engineering in order to solve the problems. And of course, we have also data science and data analytics in railways. Here I have the outline of my presentation divided in several sections. I will tell you a little bit of introduction about the data application in railways, and also tell you about the general terms of railway industry. And I will introduce some data sources of railways where we can get the data to analyze them. Later, I will start with some applications of data science in railway industry. After that, I will give you some practical examples or introduce you some examples of application of data science in research and also in practice in engineering, according to my former background of research and research education and engineering. And at the end, there will be some time for the questions. You can also follow the presentation by the left vertical bar. Railway engineering. Railways called railroad in the American English, but I'm quite used to the term railway, so I use it. And also there are some natural differences in between the railway industry in America and in the Europe, for example. So the trend for using railways and the entire railway industry in the Europe and also in some Asian countries is much more popular than what you see in the US because of the geographical limitations and also a very wide country topography in the US. But in the European countries, almost everywhere, you have a very popular form of railway transportation. Could be urban and could also be intercities, which is used every day by millions of people to as a first transportation mode. For railways, we have different disciplines and also different components which determine the entire railway industry for us. You see, we have civil and infrastructure, which provides us a facility in order to put our trains there. We have electronical parts, we have energy supply, because most of the lines, at least in the Europe, are electrified. Therefore, we have many interfaces with the power supply and electronical parts. We have the mechanical parts, which are the vehicles where the passengers can sit in the train, or the goods can be carried out by the vehicles. We have a lot of interfaces with planning, scheduling, and capacity management, which are almost very vital parts of railway industry in order to have communications with the users. Of course, users can normally use the trains, and they don't sometimes understand the original interfaces or the original developments, but the transport planning, scheduling, and capacity management provides them the better punctuality, the better profit of the system. And we have to do always with the maintenance and the life cycle analysis in order to put our assets at their best of availability and their best of reliability, and of course with having always the look on the safety criteria, which are quite important, which is a quite important thinking way in the railway in general. We have a lot of data sources in railways. Here some examples are nominated. As you see, we have many measurement data and monitoring observations for the track for the track geometry, for the defects, for the geographical conditions, for the weather conditions, for whatever which is related to the infrastructure of the railway system. We have some performance data of the components, because we have many different components in the railway track, which are also quite diverse in terms of their configuration and their geometry. So every component is also prone to defect or prone to fatigue. Therefore, there are also many observations results on the failure modes and failure circumstances. Third, we have user behavior and selection preferences, because when we know that passengers using are using the trains every day, we also have a lot of statistical data on their preferences, where they go, where they take the train, where they take off from the train, and where how many people use them, and which suppliers of the goods are willing to use the railway industry, for example. So all this information, all this statistical information are used in order to do the development and to do the improvement of the system. Next to this, we also have a lot of economical related data and business development observations, which gives a lot of hints to the railway users, to the managers, and also to the entire sector, in order to know how they have to go, whether they need to invest on new lines, new routes, whether they have to put money on new developments or not. So all this information are quite related to the data and to data science. Let's go to the applications. As I already mentioned we use the data in general for monitoring and predictions, and to do the predictive maintenance methods and predictive maintenance strategies. Of course, due to safety criteria and safety measures, we never want to have a defected track or defected train stopped in the middle of the route. Therefore, we have to always invest on data analytics methods in order to do predictive maintenance. Before we see a real disaster or a defect or accident in the reality, we have to know what will be the trend for the future, and which places are prone to defect or prone to fatigue. By the analysis of the failure routes and the inspection and improvement strategies, we are able to keep the system in a very safe and reliable condition. the data-driven decision making for management and strategic planning is used every day by the scientists and also by the engineers in order to provide decisions for the managers, and they know how to deal with the problems in the current situation, and also to know about the future improvement or optimization strategies. And finally, the active business improvements and also the insight about the capital balance and profit in the entire sector can only be obtained by very accurate knowledge, or very active knowledge about the data that we can and we have to obtain from the railway industry. All right, from this slide almost to the end, I will introduce you with some applications that I personally use in my previous and also in my current career. So there are, and also there has to be, many other applications of data science in railway industry by many other researchers, many other engineers, but these are more or less the things that I have been involved in the last almost 10 years.
May I have a question?
Yes, please.
My question, which platform you use for prediction, which algorithms or which software? For example, do you use Python, R, or business-based softwares like SPSS or other things? And also, if you, I mean, I'm not sure if it's a good time or not. Later, if you tell us the future opportunities that our students might find in the rail industry, that would be very great. Thank you.
Yeah, that's a very nice question. I will get back to this during my speech on these examples, because every example has his own history. So I will get back to this question later on. For now, let's begin with the example number 1, which is some test measurements data on the wheel rail contact. As a civil engineer, which is my background, I have been involved in the development of some testing facilities to investigate the wheel rail contact problem. You know, the wheel and rails are both steel material, metallic material, quite resistant against fatigue and defects, but they have a very highly usage when the trains are passing by. So therefore, we have millions of cycles for these components when they are in contact with each other. In order to see their performance and in order to have some idea about the fatigue initiation, we have to look at the measurement data, and of course that would be very nice if we can do the test in the lab. In TU Delft, we have developed some testing facilities, for example, this one, by which we were able to do the testing of the wheel rail contact system under the scaled configuration. By means of this testing, we were able to obtain the dynamic wheel rail contact forces, the magnitude and frequency contents of the dynamic forces, and we were able to see the variations and abnormalities in the contact forces to say something about the fatigue initiation. For example, here in this slide on the right, you see some fluctuations on the dynamic forces, which is related to the presence of rail joint. The same happens also more or less on the when we have the defects on the rail surface. So by means of this data, this measurement data, we are able to say something about the nature and the root causes for the fatigue initiation and for the defects that we might have in the reality. And if you have enough set data, if you have enough information about the origination of different sorts of defects, then we can also tell something about the remedial methods and improvement strategies in order to decrease the amount of the defects that can happen in the future. And of course, we can also tell something about the solutions in order to decrease the fatigues and also to improve the quality of the material to the extent that we have no defect anymore, at least in the normal situation. And here I have one example video for you. This I cannot stop it anymore, but no problem. That test gives us some information about the continuous rolling contact. When we have continuous contact, this happens also in the same, more or less the same configuration in the reality. This was very difficult to model in the reality because you cannot track every terrain and you cannot measure everything in the reality. But in the lab, it's much more easier and much more quicker to simulate and to generate fatigue. Therefore, by means of lab data, we are able to obtain millions of data sets per week, for example, for related to different testing methodologies. In fact, this is very difficult to obtain in the reality, but in the lab environment, it is much faster, and then you can get a lot of data, and by processing this data, you are able to tell something about the origin of defects. How we analyze this data was mostly based on written programs in MATLAB. So for this, we didn't use Python, for example, or other advanced SPSFs or other advanced tools in order to analyze them, because these are not yet in the level of big data. So they can be analyzed yet by the available tools or available programs, or the methodologies that can be defined by the user in MATLAB, for example. Example 2 is the data impact on tests of the track structure. We also did, next to the former one, we also did some hammer test measurements or impact test measurements, by means of which we were able to.
Dr. Naeimi,
Yes.
So basically, you want to say that you have some lab data because it was easier to get. So based on your lab data, you made some predictive model. Then later you use them for analyzing the probability of failure, predicting probability of failure in the, real case scenario, right?
For this one, it was quite simple, because when you see the abnormalities in the contact force, for example, then you can correlate it quite easy with the geometrical abnormalities, for example, rail joint or rail defect. So for this, the inputs are not quite complicated for the decision making part. But there are some other examples where you have to be able to model it in a better way in order to have the more advanced prediction model. For these two examples, example 1 and 2, a very simple method has been used, because you can simply see the abnormalities by the test results.
Okay, thank you.
As you see here, the track is under loaded or unloaded condition. We use the oscillator or the hammer to initiate impact, and by means of impact, we can tell something about the instabilities of the track components, or how the dynamic effects of different components could be related to each other, and whether we have the same output when we have defect or not. So these are all related to the dynamic nature of the track structure, by means of which we are able to tell something about the dynamic performance of the system and also about the defects. Next example is a totally different strategy, which tells us about the CT scan measurement. A CT scan is widely used for medical purposes, but it has also been used by many researchers for industrial applications. One example is shown here for a study the crack morphology and the crack geometry of the rail defects in the lab environments. We have studied a number of rail samples taken from the Dutch railway network. We studied them, we prepared the sample and put them inside the CT cabinet. We get the input CT scan data, and then we analyzed the CT scan data in order to capture the real geometry of the defects under the rail surface. You see here some examples of reconstruction methods for the rail defect under the rail surface, where we are able to see almost the entire geometry of the defect in the subsurface. This is quite difficult to predict when you don't have such information. These are in the scale of very huge data sets because when you get the CT data, they are stored in the computer, and then for analyzing them, you have to use a very powerful commercial software. So that's a little bit the difference between predictive maintenance strategies and what we have here, because these are more or less popular methods and also popular strategies to do CT scan, for example. You know, when, for example, a doctor sits behind of the CT scan, he only looked at the result and says, okay, this bone has some problem, so that there have to be something missing in the body of the bone or something like that. So I mean, for this, we don't need to develop our own software or our own programming tool to tell something about the future. This is what exactly see from the reality of the defect. So these are, of course, monitoring and measurement data, but for this, there is less need for the predictive tools in order to analyze them. So the defect that you see is quite clear when you do the scanning. Here I have another video. So you see how the defect can be demonstrated in the 3D configuration by means of the scanning. The red or the blue parts are in fact the rail fracture in the subsurface. The next example is the design strategies that we use normally for the railway track alignment. From this example to the end, I have more results about the design and engineering applications of the data science. The former three examples are mostly related to research, but of course, in the engineering applications, our daily engineering work, we always have to do or have to be involved with the data as well. One good example is shown here as the application for the alignments design. You know, when you have the geographical data of the ground, which called land survey data, we have millions of points, for example, or millions of nodes which are measured on the rails on the surface of the ground. So by means of this data, we are able to analyze and we are able to design the geometry of the track, how and in which direction the track has to go. This is the main idea of the track design. The local and the international norms and standards are used as the basis for the calculations. We have huge data which has to be analyzed by means of different software packages, and there are many limitations and restrictions involved always in the design of the new routes or in the modifications. Again, for this, there are quite well-known software packages. So most of the time we use or we import the data, the ground data in the software, and then we do the calculations there. We check the standards, we check the limitations, and of course we always look at the drawings that can be obtained from the software. But these are so huge that unfortunately we cannot access, or we cannot have a direct relationships with this data. These are not things that can be done by a personal computer, for example. So for this, all of them are commercial softwares available. The next example is about the track data sources of the infrastructure manager. ProRail is the infra manager in the Netherlands. For US, I guess you have Amtrak, which is responsible for the entire infrastructure of the system, the railway industry. The exact track geometry of the different routes has been measured and also have been available in their own the data sources. They have some special softwares developed for their organization in order to store and in order to monitor all the geometrical data available in the entire network. You see here on the left side in the part of the railway network of the Netherlands. So if you choose one specific route, you are able to see almost everything in the form of data, in the geometrical formation, and also in the text or ASCII outputs if you want to have. So you see the data of the switches, you see the data of the geometrical parts, the horizontal alignments, the vertical alignments, everything is available by this kind of software packages. So this is a very common tool for consultants and for the contractors in order to assess the current and the future developments of the railway geometry. What will happen if they want to have a new line, for example, and what is the current situation. By means of these tools, we are always able to transfer the drawings and to give some output to the users in a very real-time format. So this data has to be updated almost every day by the new data which are obtained by the consultants or by the contractors. The next example is the monitoring data sources of the infrastructure managers. The former one was when what you get at the end of the design stage. But of course, the data will be changed every day because the trains are running on the rail track. So in this case, you have always updated the geometrical conditions of the track. By means of inspection and measurement data of the track geometry, ProRail is able to give some real-time data measurements about the abnormalities and also about the geometry of the track. You see here some examples of the data which can be obtained by the infra manager. Corrugation is, for example, a type of rail defect or waveform defect on the rail surface. You can have also the data about the wear on the rail surface. You see the geometry. You can also see the speed profile of the vehicles. So a very nice mix of data about the vehicles and also about the track can be obtained by this monitoring data. And then when we want to study the defects, we have to see some correlations. We define some key performance indicators for the geometry, for example. And then by means of KPIs, we are able to say when there are some more chances for defects. For example, when you see here some abnormalities in the rail geometry, and at the same time you see some high rate of wear on the rail surface, or some high rate of corrugation on the rail surface at the same place, you can say that these are related more or less to each other. For this, there are many researchers ongoing. So people define different KPIs and people try to correlate different parameters to each other to find out which places are more prone to fatigue or more prone to defects that can happen in the future. For this part of research, I have been personally not involved for the predictive maintenance strategies, but I know that some other colleagues in the TU Delft have been quite long involved about the predictive maintenance strategies. For this, as far as I know, they have used MATLAB, but not Python. I guess Python is a more recent generation of that data analytics tool, but the guys who I already know were quite able to do some predictive maintenance models based on MATLAB. The last example is what we call it the rail traffic study data, or the rail traffic capacities. You know, every track, every route is daily used by the passengers and also by the freight trains, and the data of the usage is all can be depicted by means of this type of graphs, which are the operation graphs of each train. If you consider every train during the entire day, then you have the total network. You can see the data of the total network. And if we want to see the effect of variations or modifications in the network, we can see on these huge data sets what will be the effect of modifications on the other lines, or on the performance of, or on the performance of the entire network. For example, if somebody asks, we have in this station some problem with one route, what will be the influence of removing one route on the entire network? This can only be done in such kind of huge traffic study based programs. So if we remove one route from one station, we can see what will be the effect on another station 200 kilometers, for example, away from this station. And so if you apply any modifications on the network, on the specific part of the network, you are able to see the effects, and also you are able to judge, to have some judgment on the performance of the system when you have a new line, or when you remove a line, when you remove a switch, for example. This can be quite essential. For example, if you only remove one switch of the network, what will happen, and whether the capacity of the system will be higher or less. This can only be done by means of these huge capacity planning tools. Again, for this, there are very commercial and very huge providers of these capacity management tools. As a user, you are able to provide the inputs, and you are able to see the limitations. You can define the borders. You can define the boundary conditions of your assumption, but you as the user have not so much access to the calculation part, because it is a kind of black box for all kind of this capacity management system, and these are very huge data sets. So this was also an example that was related to my formal career, but my background is not about the industrial engineering or about the optimization of these capacity problems. So here are some conclusions. As you already saw in these examples, data analytics is often used in research and engineering purposes in railway industry in a very general form of application. For research objectives, I mentioned a couple of examples. We can do performance monitoring and predictions, and we can do the predictive maintenance by means of the data that we can get from the defects. And we can also tell something about the failure routes and failure origins by means of the inspection and improvement inspection data, and we can tell also something about the improvement strategies, how we can have a safer system with less defect. For integral design purposes, and engineering purposes, we have to look at almost every aspect of the railway industry. I mentioned some examples, for example, for track geometry, and also I mentioned one for rail traffic study. But all of these things together make a very integral system of the uh, railway engineering. So all of these components are related to some extent to make the entire system working safe. The other examples that I didn't mention are, for example, energy supply, or construction management, or management or strategies, or safety. All of these aspects are quite related to each other, and by means of having an integral view of the entire system, we are able to use the data in a right way, and we are able to provide the users with more reliable solutions and more reliable applications. All right, that was my presentation, and I will be happy to hear your questions.
I have a question regarding visualization. So this is like a railroad system and several, I mean, route sections and stations. So are you in the like, have you worked with the transportation office to see how they visualize the problems? Because I know in some institutions, or I mean rail organizations, they have some specific tools to find the problems and showing basically day-to-day report. I was wondering, have
Mhm.
you worked with those offices and know which visualization tools they use?
Uh, NS is, in fact, as you mentioned, there are many offices which are involved in this kind of studies. NS, or Nederlandse Spoorwegen, which means the Dutch Railways, is a very huge party which involves in all the operational related problems and operational related matters in the Dutch Railway. So I know that they have, for example, many departments who are involved for different aspects. Some of them are related to the operational conditions, some related to the stations, some related to the vehicles. But in general, this is not my field of research or field of career. So I'm not quite familiar with the visualization tools that they use. But these are the packages that's by means of that they are able to tell you what will be the capacity of the system when you have the modifications and when you do the improvement in the system. I personally don't know the terms. I heard something about railsys, for example, but there could be so many others as well.
Okay, I see. Thank you.
Other questions?
Yeah, I don't see any questions. So if you guys end up having some questions later, please reach me. I provide Dr. Naimi's email, so you can reach him later if you have some questions, especially about the application of data analytics in his field. Anyway, thank you very much. A very good, well-prepared presentation. We got quite familiar with the your field in the Dutch railway system. And anyway, very good. Thank you very much.
You're welcome. I hope you enjoyed it, and if, as you said, if there are more questions, I will be always available to answer them. And I hope this presentation gives some hints about the railway in a general sense to the people, to your students. And uh, my own experience is that railway is a very huge industry, is quite comparable with the aerospace. In the US, for example, aerospace is much more advanced than railways. And I guess if we use more or less the same type of work or the same strategies as people use in aerospace in the railway application, railway could also be a very competitive mode of transportation in the US in the future.
Actually, we are in the northeast. The railroad is not as good as Europe, but is much better than other parts of United States. Also, sooner or later, California would develop a good rail system. So hopefully, we see more of it in the United States too.
Yeah, because and a very good example of huge countries which use railway in a very systematic way is China. In China, you have a high-speed railway network almost everywhere. I have been sitting in a train with a speed of 350 kilometers per hour, which was quite safe and quite comfortable. So it would have been considered a very competitive mode of transportation instead of plane. If I travel, for example, between Shanghai and Beijing, I would choose for high-speed rail. It
Yeah,
was much more convenient.
yeah, I
So
work.
I guess the same strategy can also be used in the US.
Yeah, I used to work with the Chinese South Rail. I mean, department. They are really quite competitive. I think. I think they are best in the world. I guess I'm not quite sure, but you have a very advanced system.
Yeah, according to me, yes. Yeah,
I got
at
the
least for the high
experience.
speed ones, they are quite advanced, and also there are many developments in the future. So almost every month, I guess, every month they open a new high speed line.
Oh, that's
So
wonderful. Anyway,
yeah,
thank you very much. I totally appreciate it. Hopefully, later we have more of you in our classes.
yeah, I
Thank you.
enjoyed as well. Have a nice day.
Thanks. Same to you. Bye.
All right, bye bye.